Hey everyone, today we are looking at the sum of angles and difference of angles identities. So what I want you guys to see is here's our identities right here, and we'll talk about kind of why these work in just a second. But what we're going to look at is some key features and how you can kind of recognize which identity is which. So we're going to start by looking at our sine identities, okay? If we're looking at the sum of sines, okay, we're adding our angle measures. So A and B are simply angle measures, all right? We're going to add the angles, and our sine matches. So sines have matching sines, all right? And then notice we have the sine of one angle, the cosine of the other, and then they switch in the second half, the cosine of the first angle and the sine of the second. It's the same thing for difference, except that we are now subtracting. For our sum of cosines, all right, our cosines are together, and then the sines are together. And now this time, when I'm doing a sum for cosines, I'm actually subtracting in my identity. And the opposite is true for difference. If I'm subtracting my angle measures, then I'm going to be adding in my identity. And then we look at the tangent of the sum of two angles. And what we're going to look at is notice that there is a plus and subtract in our identity. The numerator is going to match whether you're adding or subtracting. Okay, our subtracting over here, our numerator is subtracting, and your denominator is the reverse. So why would we use this? So when we're going to use our sum and difference identities is if we have an angle measure that is not on our unit circle, but I could break it apart into two different angles that I know, and I can either add those angles together to make the sum, or I could subtract two angles to get that particular angle, and I could find a way to get the value of some trig functions with angles that are not actually on our unit circle. So let's just take a brief second and look about why this works. All right. So let's say that I want to find the cosine of a 75-degree angle. Well, a 75-degree angle is going to be somewhere right in here. So right here, we're going to have that this is 75 degrees. All right, and this is going to be the cosine of 75 and the sine of 75. And we're trying to figure out what those are. Well, if I think about it, I could do this one of two ways. I could say, okay, well, I know that 75 is 45 plus 30, and I can show you the sum of your angles that way. Or I can say that 75 is 135 minus 60. And this is the one we're actually going to talk about real quick. So then let's take a look at doing this up here. So if I have a 135-degree angle, that is this one right here. Okay? And if I want a 60-degree angle, that is this one right here. So if I look at this, it's important to realize that this angle right here is also 75 degrees. So one of the things that I want you to see, and we're going to talk about where these identities come from, but I'm not actually going to walk you through the entire process, is if I were to draw this triangle, and we make it one piece here, so let me group these together. I want you to see what happens if I take this triangle and I rotate it to here. Oh, because I'm goofy and I did not actually draw a 60-degree angle. Let's go back. And we're going to take this out. Sorry, my apologies. This right here is our 60-degree angle. I was wondering why that was not working. So sorry if I just confused you. But we We all make mistakes. So if I draw in this triangle, let's try this again. And we regroup these. Not that. These guys. And we rotate now this triangle. We should see that my triangles are congruent. So what essentially these identities are is if I were to do the Pythagorean theorem or the distance formula to find the distance between these points. So I know that for the blue triangle here, that this point is 1, 0. All right. For my red one here, I know that this point is this one here. So negative square root of 2 over 2. Square root of 2 over 2. And over here, it's this coordinate with 1/2 and square root of 3 over 2. All right, so if I were to do the distance formula using this point and this point, and I set it equal to a distance formula using this point, and I can just call this A and B, we are going to get matching, actually not A and B, that's not what we want here. We're going to get the identity. So I'm actually going to call this point A, and then I would call this point B. And you're going to see those identities come true. All right, again, these identities simply come from the distance formula. All right, and if you would like me to show you in class how they get there, I will be happy to do that for you. So let's take a look and see exactly kind of how this works. So we have a trig function of 105 degrees. I want to find the sine of 105. Well, we do not have 105 on our unit circle. So what we're going to do is I'm going to break this up into two numbers that are going to add to 105. So I'm going to say the sine of 60 plus 45. Now what's important is that these angle measures are on our unit circle. Okay? So if I look at my sum of sines, my formula is the sine of A times the cosine of B plus the cosine of A times the sine of B. So we're just going to call 60A and 45B. So it's going to be the sine of 60 times the cosine of 45 plus the cosine of 60 times the sine of 45. All right, so then from here, all we're going to do is we're going to use our unit circle to find these values. So if I look at the sine of 60, it is the square root of 3 over 2. The cosine of 45 is the square root of 2 over 2. The cosine of 60 is 1/2, and the sine of 45 is the square root of 2 over 2. So we're just going to multiply across the top. The square root of 3 times the square root of 2 is the square root of 6. 2 times 2 is 4. 1 times the square root of 2 is the square root of 2. 2 times 2 is, again, 4. So I cannot add these radicals together. That is something that is important to remember, because I can only add radicals when they have common radicands. What is under the radical sign is the same. Okay? So this is going to stay the square root of 6 plus the square root of 2 all over 4. And this is my answer. Okay? So let's try to work this one. And one thing that I want to say too is that there are often multiple ways to get from point A to point B. So with 165, there are several different possible angle measures that I could use here. I could do that this is the cosine of 30 plus 135. I could do that this is the cosine of 45 plus 120. Okay, both of those are completely fine, and there's probably more out there that I'm not thinking of, but it's okay. So there are multiples. You should end up in the same spot no matter which way you go. All right? So I'm actually going to use this one. That's just because it's what I had on my paper. So for cosines, it is the cosine of A times the cosine of B. Now, I am adding here, so my sign in the sum is actually subtraction. Remember, cosine signs are opposite. So then this is going to be the sine of A times the sine of B. All right, so we're going to plug in. We're going to get the cosine of 45 times the cosine of 120 minus the sine of 45 times the sine of 120. And another thing that's important to know is it doesn't matter which one you do first, which one you do second. You'll end up in the same place no matter what. All right, so what we're going to do is I'm going to go ahead and pause this right now. I want you guys to go ahead and pause the video and try the rest of this on your own. Try to get the rest of it. So go ahead and take a second, pause the video, and work the rest of this problem out. All right, so go ahead and check your work. Okay, you should be looking at your unit circle to find the values of the sine and cosine of 45 and 120. All right, remember we can't bring these together. So it's just going to be negative 2 minus the square root of 6 over 4. Okay? Now, let's look at some differences. So we're doing these two with sums. I want to do the next two with a difference. Now, can I do these with sums as well? Sure, absolutely. All right, sometimes you'll find that it's easier to do a sum, and sometimes you'll find that it's easier to do a difference. And I'll kind of, after we do these two, I'll kind of show you where I like to go with those, but there's always exceptions to every rule. All right, so with the difference of angles, all right, the thing that sometimes gets kids a little bit confused is that for breaking this 19 pi over 12 apart, I want to make sure that I have to get something bigger than 19 pi over 12 so that I can subtract it down to get to 19 pi over 12. And I'll show you what I mean here in just a second. The other thing I want to look out for is here my denominator is 12. Well, if we look at our unit circle, all right, all of our denominators for our radian angle measures are either 2, 3, 4, or 6. So we want to make sure that whatever our numerators are, we're going to be able to reduce it with 12 to get to one of those reductions. All right, again, we want it to be 2, 3, 4, or 6. So what I'm going to do is I'm going to take this and I'm going to change it to 22 pi over 12 minus 3 pi over 12. So 22 minus 3 is going to give me that 19 pi. And I know that when I have evens, I'm going to get a denominator of 6, so that's going to work. Okay, here I know that I'm going to get a denominator of 4. So what's going to happen is that this is actually going to reduce to the cosine of 11 pi over 6 minus pi over 4. And again, there are other angles that could have worked in here that would be totally fine. All right. And again, we can do the sums. And I'll kind of show you that off to the side in just a second. So when we look here, if we do it this way, our difference of cosines. Remember, with cosines, we're going to put our cosines together. So I'm going to do this cosine of 11 pi over 6 times the cosine of our second angle, which is pi over 4. Now, with the difference of cosines, we add in our identity, and then it'll be the sine of our two angles, 11 pi over 6, and the sine of pi over 4. One thing I also want to point out real quick here is sometimes I'm asked, why is this not a negative pi over 4? If I am subtracting a positive number here, right? Because if I was subtracting a negative number, then I would be adding. Okay, so please know that when you're subtracting two numbers, that second number is a positive number. So that's why this is positive pi over 4 and not a negative pi over 4. So then again, we just look at our unit circle and we go from here. 11 pi over 6, our cosine value is the square root of 3 over 2. Our cosine at pi over 4 is the square root of 2 over 2. Our sine value at 11 pi over 6 is a negative 1/2. And our sine value at pi over 4 is square root of 2 over 2. So we're going to get the square root of 6 over 4 in our first term here. I've got a negative sign here, so we're going to be subtracting. And it's going to be the square root of 2 over 4. So again, we can combine our two fractions into one term. Or two fractions into one fraction is really what I wanted to say here. To get this. Now, you do not have to write this down. I'm going to erase it. But I want to show you, a lot of people asked why we couldn't take this 19 pi over 2 or 19 pi over 12 and just say, okay, well, what if I wanted to do the cosine of 3 pi over 12 plus 16 pi over 12, which is going to reduce down to pi over 4 plus 4 pi over 3. So let's try it, okay, and see if we get the same thing. So we're doing the sum of cosines, so the cosine of each angle, so cosine of pi over 4, okay, times the cosine of 4 pi over 3. And if I'm doing the sum, my identity is subtracting, and then I subtract the sine of both angles, so pi over 4 and 4 pi over 3. So the cosine of pi over 4 is the square root of 2 over 2. The cosine of 4 pi over 3 is negative 1/2. The sine of pi over 4 is square root of 2 over 2. And the sine of 4 pi over 3 is a negative square root of 3 over 2. So this is going to give me negative square root of 2 over 4 minus a negative square root of 6 over 4. So two negatives, that's an addition. And when we look here, this is going to give me negative square root of 2 plus the square root of 6 over 4, which I can rewrite and just switch my numerators because addition is commutative to be this. And it is the same. All right? So it's important that you do realize that, yes, I can do addition, or I can do subtraction, and I'm going to end up in the same spot no matter what. All right? So I just wanted to show you that where you could see that they are both there. So then let's go ahead and do number 4. We're going to get it kind of started together. And then I'm going to do like we did last time and just have you kind of finish it up on your own. So when we look here, I have a negative 5 pi over 12, and I want to break this apart into the difference of fractions. So again, my denominator is 12, so I want to break this up into things that are going to reduce nicely. So what I like to do here is I'm going to say, okay, this is negative 3 pi over 12 minus 2 pi over 12. And this is where I really like to use the subtraction over the addition. When I have a negative angle measure, sometimes it's easier to do a subtraction because essentially you're still adding because they're both negative. So it's easier for me to see these subtractions than it is for me to see these subtractions. All right, so when we do a difference of sign, let's reduce these real quick, sorry. So this is going to be a negative pi over 4 minus, now remember, this is a positive pi over 6. We're subtracting a positive number. So when we do this, this is going to be the sine of negative pi over 4 times the cosine of pi over 6. And the signs for sine are going to match. We're subtracting here. Now, remember, we've switched. We do the cosine of the first angle, so the cosine of negative pi over 4 times the sine of pi over 6. Also, a side note is remember that negative pi over 4 means we are starting at our unit circle and we're going down pi over 4 to get our angle measure. So this is equivalent to a positive 7 pi over 4. So when you're looking at your unit circle, this is what we're trying to find, is that 7 pi over 4. Okay, you're not going to find your negative pi over 4 on the unit circle. Look for 7 pi over 4. We're going down pi over 4. All right, so we're going to go ahead and pause this here and have you finish up this problem. So give it a shot. Use your unit circle and go ahead and pause your video. All right, so go ahead and check your work. Pause the video if you need more time. And if you have questions, make sure you just see me in class. All right? But again, we're just using our unit circle here to find these values. Okay, multiply across the top, across the bottom, and combine down into one fraction. All right, so let's take a look at tangent. Okay? With our tangent, these do get a little more involved because if you look at the identity, it's a little more fun. We've got fractions and all kinds of things here. So we're going to take this, and I'm going to go ahead and break it up into an addition. So I'm going to break this up into 3 pi over 12 plus 10 pi over 12, which is going to reduce down to the tangent of pi over 4 plus 5 pi over 6. And again, you could use different numbers. You'd end up in the same spot. Okay? So let's look at our tangent identity for sum. All right, my tangent identity is the tangent of angle A plus the tangent of angle B over 1 minus, remember these are going to be opposite, and we're adding, so my numerator is addition, and then we multiply the two tangents together, tangent of A times the tangent of B. All right, so let's go ahead and plug in what we know. All right, this is going to be the tangent of pi over 4 plus the tangent of 5 pi over 6 over 1 minus the tangent of pi over 4 times the tangent of 5 pi over 6. Okay, so let's go ahead and use our unit circle and evaluate those pieces. The tangent of pi over 4 is 1, and the tangent at 5 pi over 6 is a negative square root of 3 over 3. All right, our denominator, we have 1 minus the tangent of pi over 4 is 1. And the tangent at 5 pi over 6 is a negative square root of 3 over 3. All right, so when we kind of simplify this down a little bit, what I'm going to go ahead and do is I'm going to change my 1 here to a 3 over 3. Same thing here, so I can combine my fractions. All right, so this is going to be 3 minus the square root of 3 over 3, because I have a plus and negative. And my denominator here is going to be 3 plus the square root of 3 over 3. So what I'm going to go ahead and do is I am going to get rid of my denominator by multiplying by the reciprocal. So this is going to be 3 over 3 plus the square root of 3. And we're going to come down here to the next line. And notice that my 3's are going to reduce down to 1. So I'm going to get 3 minus the square root of 3 over 3 plus the square root of 3. So now here's where we start to do some fun stuff. I want to get rid of my radical in the denominator. Okay, so we're going to do what is called the conjugate. You learned this in Algebra 2. I know we don't necessarily remember. But think about how we've done difference of signs. Not difference of signs, excuse me. I apologize. Difference of squares. Where basically we had two binomials that looked like this. And we multiplied them together. And that was able to get rid of, we didn't have a middle term, and we were able to square the first number minus the second number squared. Okay, so that is kind of our goal here, is if we want to get rid of this square root of 3, we need to multiply the top and the bottom by the opposite sign. Because what that will do is that will give us the chance to delete that middle term, and then we have all whole numbers on the denominator. So let's take a look at what happens. All right, up top, we're going to do 3 times 3 is 9. Okay, 3 times negative square root of 3 is minus square root of, sorry, I was going ahead here, minus 3 square root of 3. Then we're going to do the insides. Okay, negative square root of 3 times 3 is another 3 square root of 3. And square root of 3 times square root of 3 is a positive 3. And then we do the same thing down here, except remember, we also talked about this before where we said square, double square. All right, just kind of a little shortcut. Because what happens here is I do 3 times 3, and I get 9. And I do 3 times negative square root of 3, I get minus 3 root 3. And then I do this one here, and I get plus 3 root 3, which these now zero out. And then square root of 3 times negative square root of 3 is minus 3. So what this becomes is this is 9 minus 6 times the square root of 3. Actually, let's do 9 plus 3, which is 12. And then this is 9 minus 3 to be 6. So what we're going to do here is we're going to factor a 6 out of our numerator. And we're going to get 2 minus the square root of 3 over 6. These are going to reduce. So then my tangent of 13 pi over 12 is 2 minus the square root of 3. Okay, again, I know tangent's kind of a long haul. Just stay with me through it. So really, guys, just realize that this right here is the pre-calc. Everything else is just algebra. All right? Okay, let's take a look at this next set of directions. Okay, we want to condense this into a single trig expression and then find the exact value. So if I just want to condense it into the expression, I don't have to look at the unit circle at all. But when I want to find the exact value, that means make sure you're finding out what it is on the unit circle. So when you look at this, you should recognize that this is your tangent identity. So what we want to know, all right, is this is going to be the tangent of angle A, and these are going to be plus or minus B. So we want to figure that out. So I look at my numerator, and I see that I'm adding up here. So this is the sum of tangent angles. So what that means is that this is the two angles are 48 and 102. So this is going to be the tangent of 40, tangent of 150 degrees. If I was just simplifying into a trig expression, this would be my answer. But then I want to find the exact value. Well, 150 degrees is on our unit circle. And it is negative square root of 3 over 3. Okay? That's all that's to this. Keep it easy. Let it be easy. All right? When I look at this one, I see that my cosines are together. So that means I'm doing a cosine sum or difference. And I'm subtracting. So when I'm doing the cosine of my two angles, remember the sign for cosine is opposite. So this is a sum. So my two angles here are A and B. So this is going to be the cosine of 300 plus 15. So it's the cosine of 315 degrees. And if we use our unit circle, we see that this is the square root of 2 over 2. Okay? Don't let it be harder than that. Keep it easy. All right, so let's go ahead and take a look at one with our radian angle measures. Okay, again, we should see that this is tangent, and my two angles are 5 pi over 18 and pi over 36. So I want to know if I'm going to be adding them or subtracting them. So I look at my numerator. My numerator is subtraction, so I'm subtracting these two angles. Now, I can't combine these into one term because they are different denominators, so we're going to multiply the first term top and bottom by 2 so that I can get that this is 10 pi over 36 minus pi over 36. So that is going to give me 9 pi over 36, which is going to reduce to pi over 4. And the tangent at pi over 4 is just 1. All right, so I want you to go ahead and pause your video and go ahead and try number 9 on your own. So take a second, pause your video. All right, so go ahead and let's check your work. Okay, so I should see right here that I have a sine and a cosine, which means that I'm doing a sine sum or difference. Remember, with sine, the signs match, so I am subtracting here. All right, so we need to get a common denominator, subtract it out, and then we get 35 pi over 30, which is 7 pi over 6. And our sine at 7 pi over 6 is negative 1/2. Okay? And let's take a look at number 10. Now, all we're doing here is we are simplifying. Okay? We are not trying to find an exact value because we have x's in our angle measures. We can't find an exact value. So, again, keep it super simple. When I look here, I see that my cosines are together, which is going to be either my sum or difference of cosines. And I have 2x and 4x. Well, in my identity, I'm adding, which means I am subtracting here. Because remember, the signs are different for cosine. So this is going to give me the cosine of negative 2x. Remember that cosine is an even function, so the cosine of negative 2x is equivalent to the cosine of 2x. And that's our answer. We can't go any further than that. All right, we're going to do the same thing over here with tangent. And I want you to go ahead and give that one a try. All right, so we should see we have our tangent identity. My angles are 4x and x, and I have an addition sign in the numerator, so it is the sum of tangents. So 4x and x is 5x, so it's just the tangent of 5x. All right? I hope everything's going well, and I hope you have a wonderful day. I will see you all later.